from Python shell, which says that tuple object does not support item assignment. But in a simple word, it just says that you cannot change an existing element of the games tuple. Now let's look at another tuple which now contains 3 lists as contents. The first list is our indoor games list like badminton, table tennis, carom. But instead of saying indoor, we are explicitly listing all the contents of the list. And similarly, the second element is a list having football and cricket. And the third element is a list which has card games like solitaire, cards, and free set. We can slice games one list with 3 given element number 0 and 1 in games 1 list, which is same as the list badminton, table tennis, carom, and the list football, cricket. It should be clear that these 2 elements of games 1 tuple are same as games tuple itself, and therefore it should be no surprise that the particular equality returns true. Now suppose we change the content of outdoor list that we defined earlier, and we change the first element from football to hockey. And this is allowed because lists are mutable. Now here is a surprising thing. The first 2 elements of games 1 tuple and the games tuple are no longer equal. So why did this happen? How did games tuple were changed? If you look at games tuple, it has indeed changed. The second component is no longer list football cricket, it is hockey cricket. So we should try to answer why did the tuple games change when we changed the list outdoor. The reason is that tuple games contains references of list indoor and outdoor, and therefore when we changed outdoor list, it seems as if we have updated games as well. But then why did games 1 did not change? The reason is in games 1 we did not create a tuple of outdoor and indoor list, but we used different lists where we explicitly mentioned the games like football and cricket and so on. Okay. So in general, you can have 2 different lists which happen to have same content. Modifying one list will not change the other. So games 1 has references of different lists and games has references of different lists. So let's look at this pictorially. So this cloud shows the memory of your computer system. When we set list football cricket, we reserved some space in this memory and put this content football and cricket, and when we assign this to a list called outdoor, we really are just saying that the name outdoor holds the address where this list is stored. Similarly, we do for the indoor variable. Indoor variable is holding a reference or an address or a pointer in some sense to the place in memory where the list badminton, table tennis, carom is stored. When we created tuple games, we created a tuple in the memory, and each element in this tuple is once again the reference to list indoor and a reference to list outdoor. In other words, contents of games are very similar to the variable names indoor and outdoor. When we created games 1, we were pointing to some other references or addresses. These addresses coincidentally have same contents as badminton, table tennis, carom, which are also same in the games tuple, but these are 2 different memory locations. So when we decided to change the content of memory location which held outdoor list, we only modified one of the memory locations but not the other. And in this case, when we try to look at the outdoor element or the second element of tuple games, we get the value hockey cricket. But the second element of tuple games 1 still holds the value football and cricket. And as a result, these two tuples no longer remain the same. So, just to verify, the games tuple contains badminton, table tennis, carom and hockey cricket, while games 1 tuple contains badminton, table tennis, carom and football cricket as its first two elements. If you want to change games 1 tuple's second list, you can do so. But again, remember that we are not changing the tuple games 1, but we are changing the list which is inside tuple games. Okay. So after this change, we again get that the first two elements of games 1 tuple are same as the tuple games. So here is a short summary of sequences that we have discussed in class till now. So given a sequence, you can do certain operations. You can do indexing, where you put an integer within square bracket. So indexing gives you ith element of the sequence. And you have to remember that the first element has an index 0. Len function gives the length of a sequence. You can concatenate two sequences using plus operator. It will give you a new sequence that contains element of first sequence followed by the elements of the second sequence. You can apply repetition operator where you use star with an integer. So num times seq or seq times num, it will repeat the sequence seq num times, where num is an integer. You can slice a sequence by providing start and end index. And then there are three operations which we have not yet discussed, but they are pretty easy. You have in operation on sequence. So you can ask if some element E is present in sequence. So in will return true if E is present in the sequence, otherwise it will return false. The negation of this operation is E not in sequence. This will return true if E is not present in seq and false if E is present in seq. And then you can iterate over sequences by using for in operator. So when we say for E in sequence, this iterates over all elements in seq, which means E gets bound to one element during every iteration of the for loop. And we have seen this several times when we discussed for loop. In that case, typically we had the sequence generated by a range function, but you can have other sequences as well. So finally, another summary. Sequence types that we have seen until now includes string, tuple and list. List types are mutable, but type tuple or strings are immutable. That means you cannot change them. Hello and welcome to Programming Using Python by Electronics and ICT Academy, IIT Kanpur. In today's lecture, we will look at list comprehension. List comprehension is a concise way to build or create lists. The syntax is very similar to math's set builder notation.